which will be given by one of the largest module manufacturers in the world. Trina has expanded its capacities dramatically over the last year in particular, and is still continuing. And we are very happy to have with us Rocky Lee, who's a product manager at Trina. He is in solar for over 6 years and works with Trina since 2018. And Rocky will talk to us about better for trustworthiness, how to design long-lasting, high-power modules based on 210mm wafers. Rocky, the floor is yours.
Thank you, Michael. I'm going to share my screen. I'm very happy and honored to be here to share the Trina's enhanced reliability of 670 watts vertex panel. And I'll explain the technical details behind it and show why it's better for trustworthiness. And first, I'll give a brief introduction of who we are. And founded in 1997 and headquartered in Changzhou, China, Trina Solar is the global world leading PV and smart energy total solution provider. And we listed on Shanghai Stock Exchange in June 2020. And with original headquarters and offices across 6 continents, we have more than 15,000 employees and more than 100 strategic clients worldwide. And up to now, our cumulative shipment has exceeded 77 gigawatts and 10.5 gigawatts in this year's first half. And the total amount of power plants built by us also exceeds 5.5 gigawatts. And our business covers a pretty wide range, mainly in 3 parts. So the first part is the PV products. We engage in PV product R&D, manufacture, and sales. 210 Vertex series is our flagship product series. And we also have the Trina Tracker. The second part is the system solution. We've got the PV project development, EPC, O&M for both utility project and the distributed generation. And what's more, the third part, we've also have the smart energy, including the Trina storage, energy IoT, comprehensive energy services. And let's look at the Vertex series PV modules. Trina Solar upgraded our production lines in 2020 based on G12 210mm wafer size platform. We developed the 4 series production lines with various format design. Vertex series has 410 watts to 670 watts power range, covering the residential, commercial, and industrial and ground mount utility project. And in each segment, we have 40 watts to 90 watts power output higher above the industrial average, which can save half cents to 1.6 cents on the system side, maximize the customer's investment return. Okay, let's look at the enhanced reliability behind these panels, specifically for the highest power 670 watts Vertex panel. And in this page, I'll explain why the module reliability is vital for PV applications. Because with the development of the PV industry, the solar application actually can be found in every corner of the world. So this map is roughly divided into several climate areas, mainly from the perspective of the mechanical challenges, like the heavy snow, hail-prone, or hurricane area. As we can tell, aside from the moderate climate areas, green in this map, there are a lot of harsh climate areas, such as the blue part is the heavy snow and low temperature. The red part is the hurricane-prone area, and the yellow part is the hail-prone areas. And these extreme weather conditions pose a higher challenge to the reliability of the panel, especially the mechanical properties. So then how Trina deal with these challenges? So we have designed 1+5 quality verification mechanism to ensure the product reliability. So the 1 stands for regular IEC standard tests, which include the static load test and the standard 25mm hail impact test. And on top of that, Trina, for the first time, we introduced 5 enhanced test items. They are non-uniform snow load test, static loading under -40 degrees centigrade, 35mm hail impact, enhanced dynamic load test, and wind tunnel test. And all tests were conducted by independent third party, and the test samples are randomly picked from the mass-produced 670 watts panels, so which is crucial to reflect the real reliability of our product. This slide shows the Trina's 670 watts panels are IEC and UL certified for all the typical installation scenarios, including the fixed tailed scenario, the crossed beam installation, the shared beam installation, and the tracker system, single axis tracker installation. Under the standard installation method, the Vertex modules maintain the outstanding performance as the smaller size modules. And what's the reason behind it? In terms of this 670 watts module design, we use the non-destructive cutting technology, NDC in short, plus the optimized frame profile design. And on the upper right side is the advantage of NDC cutting technologies. So NDC cutting surface of the sail is more smooth than that of the traditional cutting method, which greatly improve the loading bearing capacity of the sail. So as we can tell from these pictures, the sail can bear bigger deformations, and the mechanical performance is almost equivalent to the full sail. Hence, after being encapsulated into the module would have better reliability on this perspective. And the lower side is the cross-section profile of the 670 watts panel, as we can tell the comparison as the conventional one. First, the broader thickness of the frame is thicker for the 670 watts Vertex modules. At the same time, we also expand the size of the frame cavity and upgrade the frame materials to higher strength alloy. So by all these means, effectively enhance the load performance of the modules. So non-destructive cutting technology plus the high strength frame design ensure that 670 watts panel can pass the standard test without effort. So on this basis, let's look at the harsher test. The first is the non-uniform snow load test. So in the heavy snow areas, the difference in the depth of the snow along the surface of the panel creates an even pressure under the inclined installation conditions. So the non-uniform snow load test specifically evaluate the ability of the module to withstand the uneven pressure when encountering heavy snow. So thus more effectively circumventing snow pressure in areas with heavy snow causing module failure. And according to third-party CGC test, Trina Solar 670 watts Vertex modules was able to withstand an uneven snow pressure up to 7,000 Pascal, which is equivalent to 2.8 meters of snow depth. And the power degradation after the test was only 0.56%. The second enhanced test is the static load test under the -40 degree temperature. And the working in the low temperature environment is one of the extreme situations that the modules may endure, so which may cause poor mechanical performance and damage. So we conducted the static mechanical load test under the -40 degrees centigrade, and Vertex 670 watts modules passed the test. And the post-test, the EL image looks great. There's no cell breakage, no micro cracks, and the degradations is within the criteria, which can prove that the modules can work safely in the extreme low temperature of the extremely low temperature environment. And then let's look at the enhanced hail test. In the IEC standard, the 25mm diameter hail size is used to test the module's hail resistance. But in the hail-prone area, such as North America, the requirement for hail will be more strict. So the 670 watts product was tested in third-party laboratory. So now with the size of the 35mm hail, so both the single glass backsheet type and the dual glass bifacial type is tested. And after the test, the module appearance was good, the AL image was good, and the module degradation was less than 1%. So proving that the mass-produced 670 watts vertex panel can withstand the 35mm hail impact. Additionally, Trina also have the solution for even larger size hail, like the 45mm size hail. And for these slides, now is the fourth one, is the partial test of the dynamic load test. So what is dynamic load test? So when the solar module mounted outdoor, the module will suffer stress on its upper and back side, which is a long-term dynamic process. So the frame, sail, etc. are subjected to fatigue stress, the process of which can be stimulated by the dynamic load test. So we conducted multiple times of the standard 1,000 cycles to verify whether the modules, where is the module's limit. So the test result shows that for the single glass type, on the upper side of this bar chart, we can tell the vertex panel can withstand 7,400 cycles, while the reference module's installation hole partially deformed at 3,000 cycles. In the lower part, the dual glass vertex panels can withstand 4,000 cycles, better than that 2,000 cycles of the reference modules. And all this test is under the screw installation. And if we use this clamp installation for the dual glass modules, then the modules can be up to 20 times the IEC standard and even higher, plus minus 1,500 Pascal load. And all these test results prove that the 670 watts vertex panel has excellent performance in resisting the fatigue stress, which prove better reliability for 25 years, 30 years lifetime outdoor application. Okay, this is the last one, the wind tunnel test. So in addition to the dynamic load test, the strong wind resistance of a module is an important test to verify the robustness of the modules, specifically in the high wind load area. So in the third-party wind tunnel test laboratories, we conducted the test on the 670 watts vertex panel and the reference M10 reference modules. The wind speed accelerate from 30 meters per second to 62 meters per second, each lasting 30 seconds. And once the targeted wind speed is achieved, it maintained for 900 seconds. And through the comparison, the free mounting hole of the reference modules was torn, and the module was blew off under the wind speed of 59 meters per second, while the Trina's vertex panel is more robust to withstand the wind speed of 62.6 meters per second. So the test result shows that the Trina vertex panel outperformed the reference modules in terms of the frame robustness by the enhanced frame design, including the thicker border, frame cavity, bigger frame cavity, and the material upgrade. And additionally, aside from the screw-only or clamp-only installation method, the vertex series can be mounted by the clamp plus screw hybrid fixation method, so which is highly recommended for extreme high mechanical load required area, like the heavy snow area or strong wind prone area. Okay, so aside from the mechanical properties of the vertex panel, I'd like also to explain the operating temperature and the hotspot risk of the vertex modules. Someone may argue that the high current or large panel means higher operating temperature and higher risk of hotspots. So I'd like to share the design and test result of the vertex in terms of these topics to clarify and eliminate the concern. First, let's look at the module's operating temperature. The 600 watts modules adopts the feature of the low voltage, high string power, which can effectively reduce the BOS and LCOE of the system. In the meantime, the current would be relatively high. So does the high current means high operating temperature? The answer is no. So generally speaking, G12 module adopts the same cell technology with the similar cell efficiency, similar encapsulation structures with a small wafer silicon module. So the light utilization rate, light reflection rate, heat exchange, dissipation conditions tends to be the same in the same unit of area. So let's zoom in the details of the current distribution of a panel to find out where exactly the high current is and how Trina designed the panel to deal with it. So on right side is the current distribution of a solar module. So when the PV got the sun's energy, it will first generate the photo-generated current, which would be collected by the bus bars on the surface of the cell, on the surface of the module. So shown as number 1. Then the current flow to the side string connector, number 2 and number 3, and the middle string connector, number 4. And lastly, it will output by the number 5 G-box terminal. So what is the current in these locations? So we can look at the left side of this table. We took the same 23% cell efficiency for both G12 vertex panel and M10 reference modules. Since both modules adopt the same efficiency, 23 same efficiency and the same P-PERC technologies, their photo-generated carriers density tends to be the same. So the current density is basically the same. And because although the G12 modules wafer size is bigger, but we adopt the 12 bus bars design. So comparing to the reference modules, the current on each bus bar is less. You can see the number here. Therefore, it can be seen that on the surface, almost 99% surface of the panel, there's no current and there's no high current. And for the side and middle, for the side string connector, middle string connector, and the G-box, yes, there is a high current, but we have special design to deal with it. For the string connectors, we enlarge the cross-section area to make the better heat dissipation than that of the traditional modules. And for the G-box, similar logic. The 25 amps, 30 amps, or even 35 amps are rated current new G-box has better heat dissipation to accommodate higher current. So after the theoretical analyze, so what is the real test data? So we conduct the test in our Changzhou test site. We test and compare the working temperature of the M6, M10, and G12 modules. And the results show that the working temperature of G12 vertex panel was at the same level as that of the M6 and M10. And it is further proved that there's no working temperature increase for G12 vertex panel. And we also got the third-party outdoor demonstration project to collect and compare the energy yield. And this project is in Incheon, compared with the reference M10 modules. These modules are all under the same ground, same installation method. And through these side-by-side comparisons for either backsheet type or the bifacial type, the G12 Vertex panels all outperform M10 reference module in terms of the energy yield. And during the test period from April to July, there is 1%, roughly 1% average yield gain for backsheet type that we can gain against the reference module, while for bifacial type, the yield gain is around 1.5% against the bifacial modules. So the reasons behind this, on one hand, there's no operating temperature increase, guarantee the basic energy yield capability. And on top of that, G12 Vertex panel has better low irradiance performance, which give Vertex modules advantage over the reference module. And aside from this project, we've also built the demonstration project worldwide to study and collect the outdoor yield performance in the different countries and different regions. And just stay tuned, and we will share it later in the near future. Okay, let's look at the last topic. It's the hotspot test. The large cell size, high current does not equal the high spot risk. I'll explain why. So the left side is the circuit diagram of 670 watts modules. So when the shadow hit one cell, so the bypass diode conducts. So the voltage generated by the other unshaded cell in the same string will be applied on both ends of the shaded cell. So then the shaded cell will become a load and consumes energy and generate heat. So what is the power generated of this shaded cell? Let's look at this formula. The power equals V reverse times IPH plus V reverse times I reverse. We can see that the power of the shaded cell is related to the reverse leakage voltage and the reverse leakage current. So the photo generated current IPH is related to the shading area. So in the same shading conditions, in order to reduce this this power, we need to lower whether the V reverse or I reverse. So the reduction of the V reverse require the number N, the number of the cells in the same cell string within the same diode protection should be less. So by the comparison here, we can find the G12 modules. There's only 22 pieces cell connected in series connected under one bypass diode, while the reference panel is 24 or 26. So the voltage at both end of the shaded cell of the G12 modules is lower. So for I reverse is related to the cell workmanship ability and the defects of the cell. So with a better workmanship and less cell defects can lower this figure. So by non-destructive cutting technologies, so the cutting surface is more smooth, so there's much less defects of the cell. And additionally, we have the ultimate workmanship ability coming from our rich production experience and the most advanced automatic production lines. So Trina further improved the reverse bias leakage current control ability for the Vertex modules. So all in all, less cell numbers plus strict I reverse current control make the panel's hotspot temperature lower. So let's look at the actual test data. So this page compares the indoor and outdoor hotspot test. On the left side is the indoor test comparison. We can tell that Vertex series, whether it's the 55 pieces, 60 pieces, or 66 pieces format, the hotspot temperatures is lower than the comparison of 72 pieces layout, M2 and M6 reference panel. And on the right side, we also compare the hotspot temperature with the M2 72 pieces, M10 72 pieces. The the hotspot temperatures is lower than the reference module as well. All in all, the above experiments have verified that the 210 modules have lower hotspot temperature and better reliability through fewer cells under the same diode protection and a strict bias leakage current control. And in the end, this page is showing some of the Vertex modules reference project worldwide. Now the Trina Solar's Vertex products have signed a lot more than 12 gigawatts orders, and many projects have completed the construction and put into operations. So we can see there are a lot of projects already in operations in different regions, in different areas, in different application scenarios, including the ground mount, the floating project, the rooftop distributed project. And the Vertex panels not only bring this green power to the customer in different countries, different regions, and different scenarios, but also maximize the benefit of the customer while its excellent performance and high reliability. Okay, the summary page. In summary, the Vertex panel has passed a series of enhanced mechanical load performance tests on top of the IEC standard test. So we also have the solution, the hybrid clamp plus screw hybrid fixation solution for the extreme weather conditions. In the meantime, the high current Vertex panel does not increase the operating temperature, and the high reliability design of these panels effectively reduce the hotspot temperatures, lower the hotspot risks. That's all for my presentation. Thank you.
Thanks, Rocky, for this comprehensive overview. Just maybe one question. So you talked mainly about 670, but you have a lot of products based on G12. Are you using same tests for the other products as well? And are results similar?
That's a very good question. Actually, all the Vertex family members are applied with the enhanced test, but not exactly the test sequences. Actually, we designed the distinguished test sequences for the different Vertex module family members. The 670 watts panels, it stands for the utility sectors. So all these tests can be represented and extended to the smaller utility panel, like the 550 watts and the 600 watts panel. And for instance, we also have some distinguished test legs, like we have the smallest Vertex member, the 400 watts, which is specifically designed for the rooftop applications. And on that scenarios, the most critical test sequence should be the static load test and the test the compatibility and the reliability with the various different racking structures. So on Vertex S, we apply the enhanced static load test up to the downforce 7,000, uplift 4,000 Pascal for that modules. And we also verify more than 10 various racking structures on that modules. So basically, all in all, this is a verification mechanism. So all the Vertex family members is tested according to the production position.
Okay, super, thanks. Maybe one final one. So what's the share of G12 products you're shipping this year and next year? Maybe do you know that from the top of your head?
You mean the capacity share?
Yeah. So do you know that?
Yeah, actually our capacity is, a majority of our capacity is the G12. Is more than 90% of our capacity is the G12.
Okay, super. Okay, thanks. Maybe you want to look at if you have still some time to look at the chat and answer some questions there. I think there were some comments. That would be nice.
Okay.